started or not? It's not showing.
Delay hoga the 10 seconds ka.
Make it a Swiggy scene. Get 100 rupees.
You can start.
Hello my dear students. So before starting, wish you a very happy new year. So yeah, this year is going to be a little hectic from the beginning because tomorrow is your pre-board chemistry examination, right? So don't worry about it. So it's my responsibility that your beginning should be happy enough by helping you with the most probable question that you are going to face tomorrow. So just waiting for the people to join over here. Yes, I can see so many of you commenting. Yes, hello guys. Yeah, definitely you can get 60 marks. That's my assurance for you. Okay, so nice to see you people here. You are focusing on your study. Pre-board is knocking the door. In this particular moment, I am here to help you to boost up your preparation. So now in this 11th hour, please don't go for the thorough revision or something like that. Means everything you have to go through, everything you have to study. No, it's not possible right now. So be precise, focus on the target zone so that with minimal approach you can get maximum effect. Okay, so be a smart worker. So yeah, without further delay, let's start. And before starting, just let me tell you, if you are also preparing for the KCET along with your board examination, then our Deeksha Karnataka channel has launched the most awaited KCET ABHYAS test series. It is giving you the 35 mock test and previous year question of the all chapters. So make sure that you are enrolling here as early as possible to get top 1000 rank in KCET. Okay, so without further delay, let's start one by one chapter. So first we will try to proceed with some short MCQ question, and then slowly one by one chapter as we will move on, I will tell you what are the target zone and which question actually you have to proceed with. So many of you are commenting which is the most important chapters and all. Yeah. So I will tell you the most important chapter. Just let me just give you a brief out of it at first. So the most important chapter that you should not skip, or you can't skip actually, better to say, that is the electrochemistry, chemical kinetics, solution. And if you go to the organic chapter, then it should be aldehyde, ketones, amines and biomolecules. Please, it's my request to you, don't skip these chapters. Okay, so majorly if I just tell you electrochemistry, you will tell me that it's a very big chapter, but trust me guys, I will tell you some specific zone from where actually you will get the question. Okay, so let's proceed with the solution. See, few MCQ let's solve at first. Let's just see how much you are prepared. Okay, so first you can see molarity of the solution is number of moles of the solute dissolved in. This is one of the question. It is a target zone, let me tell you. Maybe here I have given you the question with respect to molarity. Maybe you can get the question with respect to molality. Okay, be careful about it. So for this case, definitely it's going to be dissolved in 1 liter of solution, right? But if it is the molality, then it would be the 1 kg of solvent. Be careful. This type of question I have seen coming in the pre-board examination. Okay, next you can see unit of molarity. So from the concentration term, you can expect the units can come. Okay. So yeah, for this particular case, I can see so many of you are in super excited mood. They are giving the answer as well. Yes, it is mole per liter. So some of you are telling that it's option D, but you can see mole liter it's given. So mole per liter means mole into liter inverse, right? So option B is going to be the correct one. Okay, so let's proceed further. Which is an example for the ideal solution? So there can be the question with respect to the non-ideal solution as well. Okay, even they can ask you the question, which of the following will give the positive deviation of Raoult's law? Which of the following can give negative deviation of Raoult's law? So this is one of the question from that particular zone I just have included here. Okay, so for this particular case, you have to check if there will be any interaction in between solute solvent particle. Okay, so as you can see, acetone chloroform, acetone acetone dipole dipole interaction, chloroform is having hydrogen bonding. So yeah, we can't consider it as an ideal solution, right? Phenol aniline, again hydrogen bonding. Then ethanol acetone, again the same case, you can expect the hydrogen bonding over there. Now here you can see benzene toluene, if you just look at that, they are having quite similar type of interaction in between them. Means interaction between AA and BB will be equals to the AB interaction. So option D is going to be the correct one. So let's proceed. Here you can see the Van 't Hoff factor of Na2SO4. So yeah, definitely one type of question you can get from the Van 't Hoff factor in the MCQ. Be careful about it. If you are having any kind of non-electrolyte, let's say you are having urea, let's say you are having glucose, then Van 't Hoff factor will be 1 because they will not undergo any kind of association or dissociation. Be careful about it. Okay, or any kind of electrolyte like this, you can see Na2SO4, aluminium chloride, aluminium sulfate, this type of salt if you are getting, just dissociate them. So how you should dissociate? Na2SO4, if I dissociate, I will get 2Na plus plus SO4 2 minus. So I will get overall 3 ions. Count the number of ions you are getting, that will be your Van 't Hoff factor. So your option is going to be B. Okay, let's proceed further. Here you can see the colligative property generally used for measuring the molar mass of the polymers. So the biomolecule is, so here basically the answer is going to be osmotic pressure. Okay, so why basically this is one of the question that was taken from the I guess question bank. Even in model paper also you will see this type of question. Previous year also this type of questions were targeted. Why osmotic pressure method is taken to measure the molecular mass for the polymer? Why not other colligative properties? So be careful, this type of question may come. Okay, so osmotic pressure method we do in the room temperature. Their stability of the biomolecules are very much good, and in what happens in case of elevation of boiling point, depression of freezing point, we have to change the temperature, we have to rise temperature. That time the biomolecules can be unstable. Okay, so this is the reason I'm just sharing with you. Let's proceed. Here you can see electrochemistry, but before proceeding with the I can see, ma'am, is this marathon useful for 50 plus marks? Yes, definitely it's gonna be helpful for 50 plus marks, even more. That's my assurance to you. Okay, maybe you will get common MCQ out of it. It's my assurance to you. And before proceeding towards the electrochemistry chapter, I will tell you what are the target zone for the solution chapter as well. So here you can see the solution chapter. Here comes the questions. Here comes the question. You can call it as a paper leak to you just before one day of your examination. Okay. Trust me guys, without this question, there are no chance that you are getting any question out of this. Okay, so you can see, first you can see Henry's law, direct question you can write. So whenever you are, 2 marker question you can expect, and mathematical form also you have to mention what is P, what is KH, what is X. Please make sure that you are mentioning them. Next, very important, highly targeted zone, that is the application of Henry's law. Okay, so yeah. Answer of this question, everything I will upload the PDF for you people, so don't worry. So here you can see application of Henry's law. So it's also going to be very much important, like three applications are there, like for the bends, scuba divers that they face, anoxia, and another one is to make the carbonated beverages. Any two you can mention, 2 marker question you can get out of it. Next you can see, give differences between ideal and non-ideal solution. Okay, so there are list of ideal and non-ideal solution. It will follow Raoult's law, that will not follow Raoult's law. Like that you can proceed, 2 marker question you can get out of it. Okay, next question you can see, azeotropes and azeotropic mixture, same thing only. What are the azeotropic mixture? With example you have to proceed with. Please, the definition means, the definition I guess you remember, it's from the NCERT direct question. That is the, like, whenever the composition in the liquid phase and in the vapor phase will be similar. That's it. And along with that, please make sure you are mentioning whatever the definition you are attempting, please make sure that you are writing the example along with it. Okay, next you can see, yes, definitely my dear, you can get definitely 60 plus mark. Okay, next you can see, next question, components of a non-ideal binary solution cannot be completely separated by fractional distillation. Okay, one of the very much targeted zone for the board people. So this particular case you can just simply mention that it is because they form azeotropic mixture, and azeotropic mixture cannot be separated through fractional distillation. Okay, next you can see, give reason for the following. These are the application of the osmosis. Okay, and also make sure that you are just by hearting the definition of the reverse osmosis, and one important application you can just discuss about the desalination of the seawater. Okay, so this is the entire target zone, and here I have mentioned what actually what type of numerical you can get in the solution chapter. One numerical I just mentioned over here, it's, you can see, this is basically elevation of boiling point related numerical. So you can get the numerical only from the colligative property, that's my assurance. Okay, because it's a pre-board, right? You have a huge syllabus to cover, so they will target only the main focused zone, right? So colligative property, all the colligative property formula, please remember, from those formula direct question you will get. Okay, you can see it's a direct problem. Okay, it's not something like it's a 2 or 3 steps problem, and whenever you are just writing the problem, make sure whenever you are just after solving this, make sure you are writing the proper unit, otherwise 1 mark you will lose. Okay, next let's proceed. Okay, we will proceed now with the electrochemistry chapter. That is the most important chapter. And few of you, I guess, like they must have a fear, like okay, electrochemistry is such a huge chapter, so many numerical problem may come, but no, actually it's not. Just chill, few zone only you have to focus. Okay, so you can see the difference between the electrode potential of 2 electrodes when no current is drawn through the cell. So this is basically the electromotive force. So don't expect that many MCQ from the electrochemistry. So you can expect majorly 2 marker, 3 marker from the electrochemistry chapter, because it's a numerical based chapter. Okay, so next question, here you can see SI base units for the resistance. So it's a very important zone. So you know resistance, conductance, whatever the terminology that comes, please make sure that you are going through the units of them. Okay, whatever, resistivity, conductivity, everything unit you must have been through it. Okay, so for the resistance in this particular unit, how you should proceed, actually let me just show you. Let's say R equals to resistance equals to V by I, right? V is the potential and I is the current. So now we have to find the unit of V, right? So we can find it out from power. So power is equals to V into I. So power we know kg meter square second minus 3 equals to V into I, right? So now if I want to find out only the unit of V, that is going to be kg meter square S minus 3 divided by I is ampere, right? Now put everything here, so from here resistance unit will come kg meter square second minus 3 A minus 1 divided by A again, okay? So R is coming something like kg meter square second minus 3 A minus 2. That's going to be the unit. So your answer is going to be A. Okay, please be careful about the unit. Small mistake I have seen people doing. Okay, so go through the question where which power is used, then only you mark it. Okay, so many of you, I'm expecting you people to please participate with me. More you will participate, I can see that where actually you are lying, where actually your preparation is. So I can see Chaitra, Harshavardhan, very good. Okay, let's proceed further. Here you can see another very important zone. You can see the plot of lambda m against root c. Okay, lambda m against root c. So here another important zone from where question may come, that is the Debye-Huckel equation, right? Debye-Huckel equation. So from the Debye-Huckel equation, if I just draw the curve, very important zone, okay? You can get direct question out of it as well, okay? So here lambda m and root c, if I plot for the strong electrolyte, I will get the plot something like this, okay? Now what will happen if I extrapolate this? If I extrapolate this, then it will touch here, right? Extrapolating means what? Extrapolating means I am trying to get the conductance, molar conductivity at the concentration almost equals to 0. So it's an hypothetical condition, right? So hypothetically you can't do it, right? So that's why we have to extrapolate the graph so that we can get the molar conductivity at almost 0 condition, almost 0 concentration, okay? So that particular concentration, the lambda m value is called lambda m infinity or lambda m 0, okay? That is called limiting molar conductivity. They can ask you direct question out of it, what do you mean by limiting molar conductivity? Then you have to answer. Just a minute. Okay, so so here you will get the lambda m infinity, that is a molar limiting molar conductivity. Okay, so you can get the direct question out of it. That's what I'm telling. Limiting, what is limiting molar conductivity? Okay, so yeah, I can see few of you are giving answer. Very good. So I can see Yogesh, okay, when is the exact time of the live end? Okay, so let me just discuss the overall point of view of these chapters, what questions can come, what question may not come, which zone you have to study, which zone you can skip. Okay, then definitely the live will end. I don't have a proper plan to end the live that this particular time I can end it or something like that. Whenever your queries will end, I can end it like that. Okay. So hello students, okay, so let's proceed for the next question. Okay, so here you can see the charge required to reduce 1 mole Cr2O7 2 minus to Cr3 plus, right? So from here you can see I am having Cr2O7 2 minus is getting converted to Cr3 plus. So this particular question is basically from the Faraday's law. Faraday's law is going to be one of the most vital portion from where you can get the direct question. Okay, so from here you can see first we will balance the chromium. Okay, so here you can see 2 chromium I am getting out of it. So now we will balance the water. So here you can see 7H2 I am adding, and here you can see by default the hydrogen is coming, right? So I can add 14H plus this side. So this particular redox thing you learned in your 11th grade, but I know so many of you forgot this, but this type of question, one of them you can expect. Okay, so here you can see like now you count the total number of electron that's getting transferred. Total number of electron, 1 electron is equivalent to 1 Faraday charge, right? 1 mole of electron is equivalent to 1 Faraday charge. So whatever the number of electron, that Faraday charge you will require. Okay. Okay, so I am getting a question from Anup. Ma'am, how many marks from that important questions video? Okay, so beta, you can get 60 plus out of it. It's my assurance to you. Please trust me. Okay, please watch till end. Important zone I'm telling, and MCQ, that is the most unpredictable one. That also you can get common out of it. So don't worry about it. Okay, so here I have to add basically 6 electron. Okay, then the charge will be balanced. Here you can see 12 plus it was there initially, here it is 6 plus. So if I make it 6 electron, then it is balanced. So now 6 mole electron means 6 Faraday charge. Okay, Chaitra, very good. Okay, let's proceed further. Next, very important, I have seen these questions coming. Okay, be careful, you are just sometimes in the commercial battery, from the commercial battery portion, you are going through the electrolytes, what type of electrolytes we are using in what type of cell. That question can come in MCQ. Okay, so let's proceed. Okay, I have seen people they are answering option C, but let's see what is the answer. The electrolyte used in lead storage battery. The electrolyte that is used in lead storage battery, so that's going to be electrolyte, my dear. It should be 38% sulfuric acid. Okay, it's not C, my dear. Okay, let's proceed. Okay, so before proceeding to the chemical kinetics chapter, let me just give you an overview from the electrochemistry chapter. Please remember, it's going to be very vital for you. So here you can see electrochemistry. Okay, so here comes the question list. You can see the lists of question with the year, so many times they are repeated, so you can expect sure short question out of it. Yes, MCQ, see, MCQ is the most unpredictable zone, my dear. Okay, so MCQ, hardly I can tell you that these particular zone the MCQ will come. Okay, and this type of MCQ you may face, and yes, as these questions are repeated, this type of MCQs are repeated year by year, so you can expect common MCQs as well. Okay, so yeah, let's see. You can see the questions. Salt bridge, very important. What is salt bridge and what is the function of salt bridge? Please don't forget to study that. 3-marker question you can get out of it. Okay, next you can see what are inert electrode. Okay, inert electrode means the electrode that only provides the surface area for the reaction. Okay, it will not take part, like palladium, gold, platinum, this type of things. Okay, next here you can see define the limiting molar conductivity. I told you, very important question, very important question. So take the reference of Debye-Huckel equation, and from there you explain for the strong electrolyte we can get this type of straight line. If you extrapolate, then at the 0 concentration you will get the lambda m0. Then you tell the definition that at 0 concentration the molar conductivity of the electrolyte is called limiting molar conductivity. Okay. No, I am not going to do only MCQ. As you can see, I am going through the questions as well. So if any question you need the answer, please comment me below. I will be solving that particular question in front of you only. Okay. Okay, hello Darshini, nice to see you here. So you people, it's very nice to see you people that you are focusing on your study in this new year, without going for a party, without going for a celebration. You are here for study. Okay, nice to see you people here. So here you can see next question. It is state coal rush law. It's a direct question. Okay, so whenever you are just writing the coal rush law, direct statement, you can write from the NCERT by hearting it, and please make sure that you are writing one mathematical expression of it. Means let's say molar conductivity of NaCl you are writing, then that is equals to the molar conductivity of Na plus plus Cl minus, that you write. Okay. Yes, beta. Even if I tell you this particular video is more than enough for you to get 60 plus. Okay, that's my assurance. Okay, where is this PDF? The PDF will be uploaded, my dear, very soon. Okay, the PDF will be uploaded. Okay, so now here you can see, give like 2 application of coal rush law. That is an application part of coal rush law, but like you can proceed with the more numerical problem of the coal rush law. That will be more beneficial for you. Okay, that is also an application part only. Okay, so name the types of batteries and in commercial cell. Please be careful. Next, state Faraday's second law and first law. Both of them, you can see so many here they are repeated. Okay, please be careful. You are going through Faraday's first law and second law properly. Okay, next, explain the methods to use prevent corrosion. I guess you know that a galvanization, oiling, painting, so many things you can just proceed with it. Okay, next you can see this is a problem, what type you can expect over there. So see, please make sure you are noting this thing down. From here only that you can get the numerical problem for the electrochemistry chapter. First is Nernst equation, direct Nernst equation application. This problem you can see. Okay, next, second is del G and K relation. Okay, del G equals to minus RT ln K. That particular equation you will get the problem. Okay, and del G and E cell related problem you will get. Del G equals to NF E cell. These are the 3 particular zone from where you can get the numerical. Another thing, from the coal rush law you can expect one numerical. One I have like listed here, you can see. From the coal rush law direct application you can get one problem, and from the conductance there is lesser possibility to get the problem, but please focus on the Nernst equation and coal rush law. Very highly important zone, because it's a pre-board, right? Very selective part you have to proceed. Okay. So yeah, aldehyde ketones we will come thoroughly, one by one we will come to that chapter as well. Okay, let's proceed. Okay, so we will proceed with the chemical kinetics chapter right now. Easy chapter, important chapter as well. Okay, so I would like to ask you people, how much you people are confident about tomorrow's examination? Hello, my dear. How much you people are confident? Please tell me. Please let me know. Are you really ready to begin a new year with an excellent examination? Please let me know. Okay, Jyoti, please don't be angry. I know it's a new year, it's a time to celebrate, but please don't be angry, because it's a part of life, right? Giving examination and doing good, right? Okay, I can see Austin is saying 70%. Okay, so someone is saying I can see it's panicked. Okay, don't panic, my dear. Don't panic, my dear. Exam is a part of life, my dear. The way you celebrate the new year, in the similar way you celebrate the exam as well. Okay, so okay, I can see 50%. Okay, so 50% after like it will come. See, let me tell you, whenever my pre-board examination was there, last night was the best night, right? The preparation that you do just before the examination, that is the best one, I feel, right? Okay, let's proceed. Okay, you can see rate constant of a reaction. So here we started the chemical kinetics chapter, one of the most important. So from the chemical kinetics MCQ you can get out of units, okay, units of 0 order, first order, this type of thing. Okay, so here you can see K value is given, rate constant is given, but we don't have to do anything with the value. We have to do only something with the unit, with the unit only. Okay, mole per liter per second. That unit will tell me which order reaction is this. Okay, so here what formula you can use? Mole per liter 1 minus n second inverse. That particular formula you can use, out of which you can find out the order of any type of reaction just by looking at the unit. Unit can be like, order can be anything, you know, second order, third order, even minus 3 by 2 order, everything. So utilizing this particular thing, this particular formula, you can find it out. So you can see it's a 0 order reaction. Okay, so if you just assemble this particular thing, this arrange this particular unit in this form, so it will come something like mole per liter second inverse, right? This one. So from here I can get, it is basically nothing is there, means power is 1. So 1 minus n equals to 1. From here I am getting n value equals to 0. I guess it's clear to you. So many of you are giving correct answer. Very good, very good, very good. Very good. I'm very happy. Okay, let's proceed. The thermal decomposition. Okay, this particular zone, and again very important. See, 2HI will give you H2 and I2. Usually it's a second order reaction. But when this type of reaction takes place on a metal surface, any thermal decomposition, whenever it takes place on a metal surface, that's experimentally proven it's a 0 order reaction. Okay, so it's a fact based question. You have to know. If you don't know, you can't answer it. Okay, so I guess it's clear to you. Let's proceed further. Okay, from the following plot, predict the order of the reaction. So very common type of question. Common in the sense, graphical problem from the chemical kinetics chapter is very obvious, right? So here you can see from this case, if you just want to write, this is a straight line graph, right? If you want to write the equation y equals to mx plus c, so ln of r will give you minus k into t plus ln of r0, right? So this is your y, this is your m, this is your x, this is your c. So what type of reaction is this? It is nothing but the first order reaction. See, ln of, I'm just changing the sign a little bit. I'm taking minus as a common. So ln of r0 minus ln of r is going to be kt, right? From here, if I want to find out, k is equals to, let's take the ln to log 2.303 divided by t log r0 by r. Okay, this is how you can proceed. So yes, my dear Chaitra, Divya, Ankita, very good. It's a first order reaction. Okay, let's proceed. Here you can see rate constant for a 0 order reaction. Okay, already we did this type of problem, but one more thing I just wanted to tell about it. One question I have seen coming, like they must ask, they sometimes ask this question, like which order reactions unit is similar to that of the unit of the rate. Rate itself, only the rate of the reaction. Okay, which order reaction? That is a 0 order reaction. Okay, mole per liter per second. Please remember this thing as well. Okay, 0 order reaction rate constant unit is similar to that of the unit of rate of the reaction. Okay, yeah, very good. Very good. Let's proceed further. Here we will see D and F block. Okay, before that I will tell a little bit about the chemical kinetics chapter. Okay. See, these are the question zone. Just look at that. Without these questions, there are no chance to get any question out of it. Okay, so you can get the order and molecularity difference, very famous question. I don't have to tell, you know itself. Okay, this is a numerical based question where you have to find out the order. Okay, and here you can see pseudo first order reaction, very common question. Pseudo first order reaction with an example, you can give the example like inversion of cane sugar, okay, hydrolysis of ester, this type of thing you can give example. Next you can see Arrhenius equation, direct they can ask, write the Arrhenius equation, make sure that you are mentioning the abbreviation of it. Okay, next main criteria for the effective collision, that you can get like you can write about activation energy, you can write about the orientation. Okay, that will be enough. Next you can see derive the integrated rate law for the first order and zero order reaction, highly important zone. Okay, so 3 marks guaranteed if you just proceed with this type of question. Okay, 1 derivation, 3 mark. Okay, and another question is very important. Okay, you want to take screenshot? Okay, okay, I'm moving, you take a snap. Okay, I can see Syed, hi. Okay, hello my dear. Ma'am, can we score 65 plus? Definitely, why not? Why not 65 plus? You will get 70 out of 70 out of it. Yeah, Ankita, definitely you can score 65 plus, don't worry. Just proceed with the problem that I am telling you and you will definitely get so many odd questions as well. So don't worry, you will definitely get 65 plus, it's my assurance to you. Then come and comment me below, yes ma'am, we got it. Okay, I will be happy to see you people growing. Okay. Okay, so now here you can see this question, please don't forget, huh? First order, second order. One more question that I guess I forgot to mention here, that is the effect of catalyst. Okay, one more question, let me just write here. Just let me mark it as 27. Effect of catalyst. Okay, it's one of the most important question that you can expect out of it. Okay, next you can see here I have mentioned 2 major type of numerical that you can get out of chemical kinetics chapter. Here first one you can see it's from the integrated rate equation. Like this probability is the maximum that you can get. Okay, that from the integrated rate law. Okay, this question. And second is from the Arrhenius equation. From the Arrhenius equation, one problem. Be careful, don't make mistake while calculating because you are going to use a calculator anyway, and don't forget to write the unit, my dear, please. Don't forget to write the unit. Okay, so these are the major zone that I mentioned here. Okay, I can see Tejashwin, you are worried. Why beta, why you worried? Just take it as a chill. It's a new year, new beginning. Just take a chill pill and just proceed with the flow. Okay, everything will be done normally. Okay, I guess it's clear. Next we will proceed with the next chapter. Here you can see we finished 3 chapters, right? Let's proceed with the D and F block elements. Important chapter. See, sometimes I have seen people, they are skipping this particular chapter, but this particular chapter has only few questions on. Okay, you don't have to go through the entire NCERT for this. Few things you study, you will get to know everything. Okay, so D and F block, here you can see first few MCQ, 2 to 3 MCQ. See, I will not give you that much MCQ that you have to study 100, 200 MCQ. Then out of that 20 you will get common. No better. I will give you very selective, like hardly 50 MCQ, and you will understand the zone. You will understand what type of MCQ you can get out of it. That's it. Okay, now here you can see which of the following D block element has the highest melting point. So this is basically is going to be tungsten. Okay, so one more problem related to this that I can tell you, that sometimes they ask which of the following 3D element 3D element has highest melting point. So that time tungsten will not be there, okay? Tungsten is not 3D. Overall D block element, then it is tungsten. But if they ask only about 3D, your answer will be chromium. Okay, be careful. Both the question important. Okay. I have seen people giving answer. Very good. Okay. So next you can see. Okay, so how to know how many marks from each lesson? Okay, so basically you can see I am already telling that what is a high weightage chapter and what is the low weightage chapter, what is the question zone. From there you can understand the overall blueprint, right? So you can proceed like that. The way I am telling you, the chemical kinetics, majorly electrochemistry is a most highly important zone. Okay, high weightage chapter that Neha is asking. So that is the electrochemistry, the highest weightage out of it. So highest weightage, I will give you the list of 6 chapter. Okay, first is electrochemistry. Next you can proceed with the chemical kinetics, solution, coordination, DNF block, and from the organic itself you can proceed with the aldehyde ketones. Okay, these are the high weightage chapter. Okay, Austin, I can see I'm worried for the KCET. Okay, my dear, at first you focus on the pre-board examination. Once you will done with it, definitely we will run again for the KCET. Don't worry. Okay, proceed. Next question, you can see one of the most highly important target zone. Zn2 plus iron is colorless. What is the reason? So this type of question they ask from the DNF block only. Okay, so you have to see if there are paired electron or unpaired electron. Okay, so definitely zinc has absence of unpaired electron. They will not undergo any kind of transition, so colorless. So yeah, the class will end like as per the convenience actually. Let me just discuss overall point of view of the chapters, then definitely we will end up slowly. Here you can see interstitial compounds. So interstitial compounds means sometime what happens in the metallic lattice, some small elements like hydrogen, nitrogen, they get trapped. Okay, those are called interstitial compounds. So overall it makes the molecule like very hard, the melting point becomes very high, the chemical inertness becomes very much prominent. So your answer is going to be all of this. Okay, I can see so many of you are giving answer. It's really very much satisfying that you people are prepared well. Yes. Okay, let's proceed. Okay, Anup, how many marks each question from your PDF? You can get, I'm telling you from the very beginning, you can get 65 plus if you follow this PDF. Yes, 65 plus if you follow this. It's my assurance to you. Okay, next you can see lanthanide contraction, another important zone. Okay, so here you can see question. So why this happens basically? Imperfect shielding, right? Imperfect shielding. So that's gonna be the major case of it. So you can see option A is going to be the correct one. Okay, here you can see Ziegler-Natta catalyst. Okay, any kind of catalyst. Oh, okay. Let me tell you what they give, like different type of catalyst, different type of reaction. Okay, reaction reagents they used to give, and you have to match them. Okay, you have to match the two side. Okay, like let's say they have given this reagent. Okay, and they have given the name in another side. Okay, let's say they have given V2O5. Okay, that is also a catalyst for the contact process, right? So this type of question also you can get, match the following type. Okay, so this is Ziegler-Natta catalyst, titanium chloride with the alkyl derivative of the aluminium. Let's proceed. Okay, before starting the coordination compound, just let me proceed with some sure short questions. Only this question you go through, D and F block will be shorted. It's my assurance. Okay, you can see D and F block, yes. Okay, so here you can see why zinc, cadmium and mercury are not regarded as transition elements, because they are having D10 configuration, no transition, no chance of transition, right? This type of question. Next you can see like 3D transition metal exhibit +2 as the most common oxidation state. Okay, this is SC except scandium. Scandium is basically, it shows +3 oxidation state. See, normally what happens, 4s2 is the outermost. So if 4s2 gets it gets released, then what will happen? You will get only D configuration. So from the s orbital, it's easy to release the electron, but for the scandium, what will happen if you release the 4s2? There will be 3d1. So another one electron, if you release from the 3d1, it will get the inert gas-like configuration. That is even more stable. So for the scandium, that's why it is +3 stable. So this is one of the question zone. Here you can see maximum 3D series which shows maximum highest oxidation state. Very important question. That is a manganese. Okay, this one is the manganese. So it shows +7 oxidation state, and +7 oxidation state compound, only it makes with oxygen. Why? That is also one of the question. Why it makes +7 only with oxygen? Because oxygen can form very strong multiple bond as well, and p-pi combination with manganese as well. So this is the reason. Okay, very good, Maya. Next, we'll upload the PDF, definitely you will get it, don't worry. Okay, so let's proceed with the next question. Name the transition metal which does not exhibit variable oxidation state. Okay, so who will answer me this question? Who will answer me this question? I'm waiting for your reply. We will keep it. We will see for the answer. Then we will proceed with the, let's proceed with the next question. Ma'am, 7 question each lesson in your PDF. How many marks each questions? Okay, it's actually, you know, I have just given you the question like what are the probable zone, like whenever it is 2 marker, 3 marker, that I'm mentioning while dealing with the question. No, I'm mentioning like the first question you can see, you can get it for the 2 marker. Okay, like this, I'm just telling you by default, means see, all the time it's not necessarily 3 marker question will be full 3 marker, right? It can be 2 + 1. That's what. Okay, like whenever I was telling that Henry's law, I told you that it will be of 2 marker. Okay, so that's what I'm telling you. Okay, very good. I can get the answer for the transition metal. Question 31. Zinc. Very good, very good, very good, very good. Okay, scandium as well, very good. Okay, next, why? Because there is no chance for the zinc, only +2 oxidation state, right? Only +2, +2, 4 from the 4s, it's gone, then only 3d10 configuration, very stable. And for the scandium also, you can tell +3 oxidation state. Yes. Okay, I have to speed up. Okay, even speed up. Okay, chalo. Next question, you can see, calculate the spin-only magnetic moment. So you can use that formula √n into n + 2, right? So first, 27, find out the number of unpaired electron by writing the D configuration, D electronic configuration. Find the number of unpaired electron out of it. Then put it into the formula √n into n + 2, and that's it. Okay, please don't forget to write Bohr magneton after your calculation. Okay, next you can see Zn2+ salt is colorless. I guess you know the reason, it's having no unpaired electron in it. Yes, Cu2+ salts are colorless. Give reason, I guess I don't have to tell you this. Again, you can see next question, catalytic properties, very important question. See, so many years it is repeated. Okay, so okay, someone is given 3.87 Bohr magneton. Very good. Round applause for you, beta. Okay, so explain the catalytic property of the transition metal. So transition metal catalytic property, why? Because they are having so much variable oxidation state, right? Any other property that you can tell? Yes, I'm at 35. Someone is telling to speed it up. So fast, answer me fast. Okay, spin only magnetic moment 1, explain. So beta, what do you have to do? D7 electronic configuration. D7, no, it is Zn27. Okay, fine. So Zn27 means what? What is the electronic configuration? Can you please tell me? Then I will solve it. Okay, it's a very nice question, ma'am. What if we don't get the same question in tomorrow's examination? Okay, so you may thinking, ma'am, you will be leaving after the live session will be end. Then if we don't get the question, who will be responsible, right, my dear? So, beta, whatever it comes out of the experience, okay, it comes out of the experience. Before coming to the live, before analyzing this question, I have studied multiple years question that may come in your examination, and then only I predicted these many questions only for you people. It means you are going to get it. Okay, so please trust on the experience and focus. Okay. Okay. Will you explain 2 markers again with the detailed information in this video? Again in this video 2 marker question. This is actually 2 and 3 marker mixed questions I am giving. Actually 1 to 5 everything I am discussing. What question you can get. Okay, so for the 2 and 5 markers specially I have made one video that you can watch actually. For the 2 and 5 marker, all 2 and 5 marker questions are there that are possible. Probably not that much actually, from all the question, from all the chapter 80 to 84 question it came, I guess. Okay, so you can go through that as well. Okay, partially filled d orbital. Okay, very good, very good. So you have studied well, I can understand. Let's proceed. Okay, very, very important question. These two, highly target zone. Any one of these you can get. Any one of this. Okay, my experience tells that you will get the dichromate, but you can get the potassium permanganate as well. Okay, so potassium dichromate preparation and permanganate preparation. So permanganate preparation, when you are studying, that time make sure that you are also studying the decomposition of the KMnO4 as well. So sometimes they ask you the question, if KMnO4 is decomposed, what gas will be evolved? So KMnO4 decomposition will give you K2MnO4 and MnO2 and oxygen. Okay, so you will get oxygen gas out of it. Okay, okay, let's proceed. Okay, let's proceed with the coordination chemistry. Yes, important chapter. Chalo. So for the coordination chemistry, you can see basically numerical problem. Yes, you can refer the model paper as well, that also I solved. We have a video of model paper 1 and 2 out there. Okay, you can check those numerical problem as well. Here actually, you know what, if I try to solve every numerical in detail here, it will be too much lengthy and it will take some time, it will consume some time to calculate and all. Okay, so that's the reason I am trying to tell that what type of numerical you should practice, that's it. Okay, there are so many numerical, my dear. Okay, there are so many numerical problem you can get out of it. Okay, but if you know from where to solve it, then I don't have to solve everything. You don't have to by heart the answers, no. Just remember from where it can come. So the way I told you in electrochemistry, only non-stick equation you focus. Okay, Cold-Rush law you focus, del G K relation you focus, del G E relation you focus. That's it. That's it. Okay, calculation you have calculated, you can proceed with it. That's it. Okay, here you can see the IUPAC name. So IUPAC name, one problem you can get out of the coordination chemistry chapter. So for this type of problem, you can see tetramine, aqua, chlorido. So okay, this will be only Cl. Okay, tetramine, aqua, chlorido, cobalt. Here oxidation state, I guess it will be 3 and then Cl2. Okay, option B is going to be the correct one. Now the question is, okay, someone is here to tell Allu Arjun. Why beta? Why Allu Arjun here? Tomorrow is your exam. I am telling you to focus here and you are telling about Allu Arjun. Okay, तो तुम लोग अलग ही मजे में हो भाई. Okay, so now you can see here if I want to find out the oxidation state, so what basically happens here whenever they will ask the IUPAC nomenclature and all, then what we do, the common mistake is to find out the oxidation state. Okay, don't do this mistake. Okay, maybe you are writing the IUPAC name entirely, but you are like missing the oxidation number over here. Sorry, oxidation number. So how to do it? You can see NH3 whole 4 H2O, here it is Cl, here Cl2. So outside 2Cl means it is balanced by 2Cl minus. So from here I can tell that this is basically plus 2 over here. So if you just dissociate this thing, you will get CO NH3 whole 4 H2O Cl. Outside charge will be plus 2. So ammonia is 0, water is also 0, so chlorine is, you know, minus 1. So from here you can get the overall charge to be plus 3, right? I guess it's clear. Yes, Sanjay. Okay, someone is first regretting that 25 is gone. So what to do, beta? 25 is gone. Let it go. Let it go. Just enjoy the new year with a new vibe, with a new jazwa. Yes, I can see Parvati ma'am solve this question. A first order reaction has half-life period of 23 minutes. How much time it will be needed for 30% completion of the reaction? Yeah, definitely I will solve this question for you. So basically what you have to do here, I am doing it for you, my dear. Okay, so first you can see half-life period is given. So T half, see I will not do the calculation, it will take time. I will just show you the way out. Okay, do the calculation by yourself. So T half is given something 23 minutes, right? So that is 0.693 divided by K. So from here find out K by doing it. 0.693 divided by 23, right? Hello my dear Syed, you will get the answer from here. Next step, your next step is put the value of K here and find the time. So 2.303 divided by T log of A0 by AT. So if I take it as A0 as 100 and 30% completion. 30% completion means I have 70% product, right? So A0 divided by 0.07 of A0. 70 by 100 if you do simply. 0.7 of A0. If you do this calculation, A0 will be cancelled out. Now if you do the calculation, put the value of K from here and calculate the T out of it. Okay, you will get it. I guess it's clear to you. Do the calculation by yourself. Okay, from here find out the K, then put the value of K here. Okay, then proceed. I guess it's okay. Let's proceed. Okay. Okay, can we get annual papers from, okay, influence, power and money. Oh my god, you wanna show your influence, power and money, so please show it in your exam paper, in your paper that they will give after you get the question paper. Okay, show your power, show your influence over there while writing it. Okay, so yeah, let's proceed. Yeah, R0 by R, yeah, same thing, A0 by A, R0 by R, same thing only. Okay, let's proceed. Here you can see geometrical isomerism is not possible. Okay, so geometrical isomerism is not possible in case of tetrahedral. Okay, so let me just show some probable zone, most probable zone from this particular case. We are proceeding with the chapter coordination, right? Chemical kinetics, coordination. See beta, here are the question list that you just have to proceed. Okay, so yeah, please solve it my dear. Okay, can we get it before? No my dear, please solve it by yourself. No influence, no money, no power. Okay, so okay, here you can see the list of question, okay, that you can expect from the coordination chemistry. So here you can see ambidentate ligands, heterolyptic, homolyptic, heterolyptic concept, ionization, isomerism. So there are so many isomerism I know, but ionization isomerism is the most repeated one. Okay. Geometrical isomerism go through properly, and they will give this type of compound, and you have to write all the probable isomers out of it. Okay, I guess it's clear to you. Here you can see it's the most important question. 2 questions are assigned here for the 3 marker. Okay, these 2 are for the 3 marker. The first one you can see octahedral splitting, you have to write a short note, 3 marker question you will get, and any one of these compounds only you will get. They will ask you to detect the hybridization, magnetic properties and geometry, any one of it. Okay, 3 marker question. Let's proceed. Okay, haloalkanes and haloarenes. So haloalkanes, haloarenes, at first let me just discuss the proper questions out of it. So definitely some name reactions are there, Finkelstein, Schwarz reaction. Here you can see difference between SN1 and SN2, very important question my dear. Racemic mixture, what do you mean by racemic mixture? Woods-Fittig reaction, only Fittig reaction, direct question you will get, only you have to explain the reaction, 2 marker question you can get out of it. Okay, next here you can see very important SN1 reaction mechanism, very important. SN1 reaction mechanism, 3 marker question you will get out of it, and SN2 mechanism also there are probabilities. Okay, so here just let's in a single glance we can see a little bit of MCQ of SN1, SN2, not SN1, SN2, sorry, haloalkanes. So these type of MCQs you can get, you can see the what type of solvent in what type of reaction. Okay, majorly, okay, I can see ma'am model paper was a bit long. Will the preparatory be tough too? No beta, it will not be tough, chill. So 7 years ago my cousin bro got it. Okay, seriously, your cousin brother got the question paper? So don't you think that it's not something that you should do as well? You should do it with your own potential. So yes, don't follow your cousin brother's footstep. Okay, so now here you can see, no, preparatory is going to be super easy my dear. Okay, don't worry, nothing is easy and difficult. If you know the thing, you can do it by any means. Okay, here you can see SN1 reactions are generally carried out in what type of solvent? So it can be SN2 as well. Okay, so here the question how you should answer SN1 intermediate proceeds through carbocation intermediate. It's a charged intermediate and hence you need polar solvent to stabilize it. Okay, so A is going to be the answer. Okay, next you can see tertiary alkyl halide are least reactive towards SN2 reaction. So tertiary group, how it looks like. So here you can see the bulkness. So whenever SN2 reaction is going on, backside attack needs to be prominent. Nucleophile attacks from the backside. If the backside is blocked, right, how it will approach to the carbon? So that's the reason steric effect. Okay. Don't worry beta, you will get the PDF, you will get the PDF, watch till end, you will get the PDF. Don't worry. Here you can see SN1 reaction of optically active alkyl halide. Optically active alkyl halide. Okay, so if you are having optically active alkyl halide, SN1 reaction is going on, you will get the racemic mixture out of it, R and S both. Okay. So racemization will take place here, and SN2 case you will get inversion in configuration, means if you are starting with R, you are ending with S. Okay, that is called inversion in configuration. Okay, so here you can see the optical activity of the racemic mixtures are because of the internal compensation. So why internal compensation? Basically what happens in the racemic mixture? In the racemic mixture I am having similar amount of R and S 50-50, right? So R is clockwise, S is anti-clockwise, so their optical rotation cancels out each other, they nullify each other. Hence this is called internal compensation. Okay. Okay, let's proceed. Someone is saying option C. No beta, it's not option C. Chirality, No, it's racemic mixture is basically internal compensation. Okay, both it's R and S, right? Chirality makes a molecule active better. Okay, Karan Singh is in festive mode. Okay, very good. Okay, so alcohol, phenols and ethers. At first, let's discuss the important zone, then we will come back to the questions. Okay, MCQs. Okay, please, my dear student, it's my request to you, please, by folding my hand, I'm requesting to you, don't skip at least this minimal amount of MCQs that I'm doing for you. Okay, I'm not keeping hundreds and 200s of MCQs. I'm keeping a very limited amount of MCQ. Please make sure you are doing it. It's my assurance you will get common. You can get 65. No, not 65. You will get 70. Don't worry, my dear. Let's proceed. Okay, chalo, let's proceed with the alcohols. Here is it. Okay, so very important question. Please don't skip this question. Very limited questions are there. Here you can see first question is related to Lucas reagent. So they can directly ask you 1 marker question that what is Lucas reagent, or they can ask you the 2 marker question, 3 marker question as well, that what is Lucas reagent and how will you distinguish the alcohols using the Lucas reagent. Okay, next is you can see Cole's reaction. Okay, 3 marker question you can get out of it, 2 marker question you can get out of it, phenol to salicylic acid. Okay, see so many repeated question. Okay, Riemann-Tiemann reaction, very important. Okay, 2 marker. Explain the mechanism of dehydration of ethanol to ethene. Very important question. 3 marker question. Mechanism, 3-step mechanism is there. Please make sure you are writing it properly. Each steps of the mechanism carry 1 mark. Cumin to phenol. Very important conversion. Okay, 2 marker question you can get out of it, cumin to phenol conversion. Another question, it can come in the MCQ as well. Whenever you are doing the cumin to phenol conversion, what is the byproduct you will get out of it? Okay, that is acetone. Remember this. Okay, still we have to revise you. We are revising, my dear. We are revising only. Okay, let's proceed. A little bit MCQ from the alcohols so that you can get the idea. Okay, so here you can see in vinylic alcohol means C double bond C direct OH. Okay, this is called vinylic unit. Okay, so here you can see this carbon hybridization is sp2, right? sp2 hybridization. So basically how to get this hybridization out of it? So you can calculate the steric number, that is the number of sigma bond plus number of lone pair. So if you count it, it will come 3 and hence sp2 hybridization. So sp2 hybridization, it can come from the benzene ring as well, from the alkene as well. So option D is the correct one. Okay, let's proceed. Ankita, can you please a little bit precise? I didn't understand which mechanism you are talking about. Okay, so if why 550 plus, my dear, target for 65 plus, definitely you will get it. Okay, identify the product A for the following reaction. Okay, so I am having here palladium or platinum. So it is a normal hydrogenation reaction. So if you do hydrogenation of aldehyde, you will get alcohol. Okay, let's proceed. Here you can see the reducing agent used to reduce. Very important, which reducing agent is used in which time. Okay, be careful about it. Reduce carboxylic acid to primary alcohols. Okay, so that's going to be, your answer is going to be option C, lithium aluminium hydride. Okay, proceed. Solubility of alcohols in water. Why? Because hydrogen bonding, right? So your ability to form hydrogen bond, this one. Okay, Let's proceed. Here you can see oxidation of phenol by chromic acid. Oxidation of phenol. See, if you are having, let's say, phenol, and if you are having chromic acid, that is H2CrO4, you will end up with this type of compound. And this is called benzoquinone. Let's proceed. Here you can see from Williamson synthesis, preparation of which type of following is possible. You can get both symmetrical and asymmetrical ether out of the SN2 reaction. So option C is going to be the correct one. Let's proceed. Here you can see byproduct obtained during the preparation of phenol from cumene. Very important question, my dear, very important question. That is the acetone. Okay. Okay, Ankita, dehydration of alcohols. Any kind of that type of reaction, I mean dehydration of alcohols to ethers, it is important actually. Okay, but ethanol to ethene, that is the most repeated here question. That's why I mentioned over there. Okay. Will they give hydroboration reaction? No, hydroboration reaction mechanism they will not give. They will give you the reagent. Okay, and always remember in the terminal carbon OH will be added in the hydroboration oxidation. That's it. Let's proceed. Okay, I guess now I don't have to tell you the name of the reaction. Can you please tell me the answer for this question 40? Please, fast. 40 is going to be the RT reaction, right? Raymer-Tiemann. Proceed, proceed, proceed. Okay, aldehyde and Yogesh, numericals, we already discussed actually a little bit because I'm not going for the thorough calculation and all. We are now focusing on the organic chemistry actually. Aldehyde and ketones. Okay, let's see the probable question zone. Aldehyde ketone. Here. Very important thing, very important chapter. Okay, aldehyde from ester, how you should prepare. So you can use basically dibyl H. Okay, dibyl H you can use for the ester to get the aldehyde. Okay, next you can see reagent for the etard reaction, very important. Etard reaction, Stephens reaction, very very important. Anyone they can give for the 2 marker. Okay, that is the chromyl chloride. Here you can see what is etard reaction. Very important question. Repeated here it came, and my guts saying that you will get this question this time as well. Gattermann-Koch reaction, very important one. From the benzene you will get benzaldehyde, right? Next you can see mechanism of nucleophilic addition. So for this nucleophilic addition, let me tell you, just focus on this HCN. Okay, mechanism of addition of HCN to aldehyde and ketone, that is also a nucleophilic addition reaction. 3 marker question you will get. So this reaction CN minus will attack over there and you will get a tetrahedral intermediate out of it. Okay, make sure you are practicing this. Okay, next you can see the question Clemenson reduction, Wolff-Kishner reduction, common question you can get. This question is important one. How do aldehydes and ketones react with NaHSO3? Okay, take with Vinu is saying good morning ma'am. So basically this is not morning, my dear. Okay, so let's proceed. NaHSO3, this is a very important question I was telling. So one more question can come from the same zone here. If you are having the mixture of aldehyde and ketone, then how you can separate it? Okay, by using NaHSO3, because it forms a crystal that is soluble in water. From there you can separate the aldehyde and ketone, and then you just put some dilute alkali, you will get your aldehyde back. That's it. Okay, let's proceed with a little bit of MCQ, my dear. Okay, let's go. Okay, benzaldehyde. Chalo. Yes, my dear, these questions are enough, more than enough if you practice. Okay. Sheikh Muhammad, beta, I am trying my best. I am trying to go as fast as possible, my dear. Okay. Okay, good afternoon, sir. So, I become sir for you. Very good. Chalo. Benzaldehyde and acetophenone on heating with sodium hydroxide. it gives benzyl acetophenone. Okay, so basically you are having one aldehyde, two different type of aldehyde, right? You are getting two different type of aldehyde, you are hitting it with alkali, right? So definitely this cannot be a Cannizzaro reaction, right? This cannot be a Cannizzaro reaction because alpha hydrogen present over there, right? So definitely it's an aldol condensation. Now same type of molecule will give you aldol, self-aldol, two different type of like carbonyl will give you cross aldols. Hence your answer is going to be option D. Okay, let's proceed. Oxidizing agent used for the etard reaction. Yes, very common question. CrO2, Cl2. Next, product obtained when ketone is treated with hydroxylamine. Okay, so basically if you are having, let's say I'm just taking a random ketone, okay? Hydroxylamine is something like NH2OH. So basically it will be something like C double bond NOH. Here R1, R2. So this particular functionality you will get and it is called oxime. Okay, NaHSO3 question you explain once, ma'am. Okay, so basically if you are having this type of aldehyde, you know, so that aldehyde that also undergoes nucleophilic addition, HSO3 minus, okay. So that NaHSO3 it reacts with aldehyde, okay. Let's say you are having a mixture of aldehyde and ketone, fine. Then that NaHSO3 it will undergo nucleophilic addition reaction and it will majorly react with aldehyde. Why? Because aldehyde is more reactive than that of ketone. Got it? So aldehyde it will proceed further for the reaction. So it will, like, the normal addition will take place, then one proton transfer, one step is there, one salt it will form, one complex it will form. That is a water soluble complex. You can crystal it out and you can just separate it. So ketone is not reacting, ketone will be there in the reaction and aldehyde will proceed for the product formation and you can separate it. Okay, after separation put some dilute alkali or dilute acid, you will get back your aldehyde. So now ketone is there in your reaction content and aldehyde you separated. Okay, so that is how you can separate the aldehyde from the mixture of aldehyde and ketone by using NaHSO3. I guess it's clear to you. Okay, let's proceed. Here you can see decarboxylation reagent. Okay, this is soda lime, right? NaOH, CaO. So many times, you know, I also wrote in my examination once, which examination I can't recall right now. I wrote lime soda here. Okay, so if please don't do this type of mistake, please write positively soda lime if it is not coming in MCQ. If it is coming in MCQ, then NaOH plus CaO. Okay, let's proceed. Okay, here you can see aldehydes which answers Cannizzaro reaction. They should not contain alpha hydrogen, my dear. Okay, let's proceed. Ammoniacal silver nitrate solution is called what? Ammoniacal silver nitrate. Who will tell me the answer? Very easy question, very easy question. It's basically Tollens reagent. Okay, one more thing very important I forgot to tell you from the aldehyde ketone chapter. Felings and Tollens. Okay, these two things please study. I forgot to mention over there. Whenever I will upload the note for you, I will upload the PDF for you. There I will mention this question as well. Felings and Tollens reagent. So as you can see, Tollens reagent is basically the ammoniacal silver nitrate. But whenever it comes to the Felings reagent, let me just discuss a little bit so that it can help you. It is the mixture of Felings A and Felings B. Okay, Felings A is basically the copper sulfate solution and Felings B is basically the Rochelle salt. Okay, alkaline Rochelle salt. If you mix Felings A and Felings B in 1:1 ratio, that will give you the Felings solution that will oxidize the aldehyde to carboxylate, right? That will oxidize the aldehyde. Okay, and you will get brick red precipitation. Okay, that is the thing. Okay, let's proceed. Here you can see amines. Important chapter, questions from amines are the short. Let me tell you, questions from the amines are short. Please make sure you are just going through it. Let me just tell you the question at first. Yes, amines here. Okay, so here you can see first question, Hoffman-bromamide reaction. See, so many years repeated. So it's gonna be a short question in your examination. Okay, so yes, hemiacetal, hemiketal, you can proceed, but the thing is, I didn't see this question coming in repeated here. So for your safe zone, you can definitely proceed with it. Okay. Yes, my dear, these questions are short for your board exam as well. Okay, so let's proceed further. Here you can see adenes, the decreasing order of the basicity of amines. So here, very important question, because this particular question has two different tricky answer. One order like for the aqueous phase, different order for the gaseous phase. Be careful about it. Okay. Next you can see carbylamine reaction, very important. Which type of amine gives carbylamine test? Very important question, repeated here it came. Next, Hindenburg reagent, short question you can get out of it. What is a Hindenburg reagent? You can get 1 marker question. And how you should distinguish if this part question is attached, then it's gonna be a 3 marker question. Okay, next, Gabriel thalamide reaction. They can ask you the question, what type of amine will give you the Gabriel thalamide, what type of amine you will get out of Gabriel thalamide? So primary amine is going to be the answer, and entire Gabriel thalamide reaction you may have to write. 3 marker question. Okay, so these are some short question from the amines. Okay, let's proceed. Let's proceed. Here you can see, okay, Shaikh isn't too much hurry, my dear. Okay, let's proceed. Amines, some question from amines. Wait. So Hindenburg reagent already we discussed. It is the sulfonyl chloride. Please go through the things. It is sulfuryl. Okay, sulfonyl is going to be the answer. Next you can see carbylamine is answered by primary amine. Okay, short questions. Here you can see which of the following can exist in zwitter ion. Information based question. Okay, you can see if you are having this thing, this is sulfonilic acid. It can exist in zwitter ionic form. Zwitter ionic form means it has both acidic and basic unit, and hence they can exist in charge separated version. Hence they can exist. This is the basic unit, this is the acidic unit, this is the acidic hydrogen. So acidic hydrogen acid will release and it will make SO3 minus, and here the base will accept that acidic hydrogen and hence it will form plus. This is the zwitter ionic form of the sulfonilic acid. Okay, proceed. The shape of CH3 is pyramidal. Okay, I guess the first option is going to be the correct one, because it cannot be sp2 hybridization, and definitely has 5 valencies are arranged in pyramidal shape. That's also not true. Unpaired electron present on nitrogen, definitely it's not delocalized. Option A is going to be the correct one. It is sp3 hybridization. Yes, one non-bonding electron pair is there. I guess it's clear. Yes, let's proceed. Aniline is less soluble in water than ethylamine. Why? Because aniline is having one aromatic ring. That aromatic ring is hydrophobic in nature, right? Compared to that, ethylamine is a small group that is comparatively soluble. So, option C is going to be the correct one. Let's proceed. Okay. Important question from the basicity of amines. One question you can get out of the basicity of amines. Please be careful. Okay, which of the following factors affect the basic strength? Inductive effect, steric hindrance, solvation effect, solubility. Okay, definitely inductive effect is going to be the correct one, because inductive effect, if plus I effect is there, that will push the electron cloud density and there will be more electron cloud to be donated. Basic character will increase. Next is steric hindrance. So steric hindrance, what happens is, let me explain a little bit. let's say I'm having only aniline. So aniline lone pair is participating in the resonance, right? So the lone pair is not available that much for the donation. So basicity decreases. But here if I add this bulky group, what happens? Because of the steric hindrance, it will make the NH2 out of plane, and hence NH2 lone pair will not take part in resonance. As a result of this, it will available for the donation. Basicity will increase. Solvation effect, definitely that's also going to hamper the basicity. So your answer is going to be B. Proceed. Okay, biomolecules, the last chapter. Finally, we are at the end of the session. Yes, here you can see the most common question that you can get out of biomolecules. Here are the question. Very important chapter. I heard students skipping this particular chapter, but please, my dear student, don't skip biomolecules, because if you go through only this question, you will get it. You will get the common out of it. Okay, let's proceed. Here you can see reducing sugar with example. Okay, non-reducing sugar with example. Properly you have to tell the reducing sugar, like let's say in the open chain form, glucose is having one aldehydic unit, right? That can reduce the Felix reagent, the Benedict's reagent, right? So glucose is one of the example. Yes, Shaikh, it's near to be the end. Yeah, now you can see how does glucose react with hydrogen iodide, or how do you show that glucose contains 6 carbon atoms? Very important question, my dear. Entire structural analysis of glucose is important, but these questions are repeatedly coming, this 74 and 75. Okay, so basically if you just heat glucose molecule, you will get a 6-member chain, N-hexane, right? That will tell you that yes, glucose contains 6-member carbon. Okay, now here you can see how does glucose reacts with the hydroxylamine. Okay, this is one of the most important question, because it is having one C double bond or carbonyl unit over there, so it forms the oxime over there. Okay, here anomers and epimers, be careful, any one of the definition you can expect out of it. Next, peptide linkage. Okay, next here you can see proteins. Here I have seen multiple years different type of question comes, give one example of fibrous protein, give one example of globular protein. Okay, so I just directly gave this question so that you can understand the zone, how are protein classified on the basis of structure and molecules and shape. Along with the example you have to study. Okay, proteins in hair, I guess you know better than me, it's a keratin. And any one Haworth projection, it's very common, that is glucose, maltose you can expect. See, maltose has a very high probability to come because repeated year it came. Okay, so let's proceed. Okay, few more MCQ problem. Okay, chalo. Here you can see nucleic acids. Nucleic acids are polymers of nucleotides, right? Next, here you can see the number of peptide bonds in tetrapeptide. If you are having tetrapeptide, means 4 amino acids, they are linked with 3 peptide bonds. So 3 is going to be the correct one. Next, the alpha D glucose and beta D glucose differ from each other due to the difference in carbon atom with respect to this configuration. Okay, not conformation. Conformation is something that we get out of the rotation of the molecule. Okay, let's proceed. Here you can see amylopectin is a dash polymer of alpha D glucose. Okay, it's a branched polymer of alpha D glucose units in which the chain is formed by glycosidic unit. Let me tell you, my dear, always formed between carbon 1 and carbon 4. Always glycosidic units are formed between carbon 1 and 4. Linkage where the branch occurs by carbon 1 and 6. Always. Okay, so your answer is going to be option B. So here I guess I have, here you can see the structure, alpha D glucose, carbon 1 and carbon 4, they are having the glycosidic linkage, and carbon 1 and 6, they are having the, branching. Okay, I guess it's clear. Now you can see proteins are the polypeptides of L-alpha amino acids. It's clear. Here you can see among the following vitamins, that one whose deficiency causes rickets. So that is basically vitamin D, right? Yeah, I guess we covered the entire zone. Please make sure that from here you are not cutting anything. I already cut a lot of things for you. These are the entire thing that you are going to get in your exam paper, okay? And please don't forget to comment below once you are getting the same question here, okay? I would love to go through your comments, so to get even better, like I mean to say informative videos and all, please don't forget to subscribe our Deeksha Karnataka channel, and don't also forget to enroll yourself in KCET ABHYAS test series. So for today, I'm ending the live session. Happy New Year to all of you, and all the very best for your coming examination. All the very best. Thank you so much.